Hello developers, let's start developing. I am Veko and we're taking the penultimate task, day 24 of the 2024 Advent of Code calendar. So this time for the first part we have a relatively simple thing. We have a logical circuit, so to say. These are the inputs that we have, and then we need to calculate some outputs. Specifically, we need to calculate the Z outputs. We have three types of logic gates that work in the expected way. We have AND gates, we have OR gates, and we have XOR gates. So, in this case, we have 1 and 0. This will output 0. We have 1 and 1. This would output XOR. This will output 0. And we have 0 and 1, and this will output, or 1. This will output 1, which means that our result will be basically a binary number Z02, Z01, Z00, which means that our result will be 4, actually. The binary number 100, 100, which is also known as the decimal 0. We have a larger example here, so everything stays the same. The X and the Y's are the inputs, the Z's are the output, but we might have some or lots of intermediate gates. So how do we do that? Well, the first thing that we're gonna do is we're gonna parse our input. And this is what we have. So we have, let's say, define it like this. So we're gonna have what? We're gonna start with having our actual inputs, which is gonna be an array of, is an array or a map better here? No, we will transform it into a map, but for the input we want the simplest way that we can want to do. We don't want to input any kind of logic inside our reading of the input, because the main goal of this method is to make sure that whatever we have in the file is ingested in the application. Then we can massage it around. So this is gonna be an array of objects that have a gate name, which is a string, and a value, which is, here we can take two approaches. We can take the ones and the zeros, but I will actually define yet another type. And this kind of goes against what I just said, so I will define a gate that's something that has a name, which is a string, and has a value, which will actually be either true or false or unknown. Yeah, something like this. I will use strings here, not values. Of course, we can use true, false, and undefined for booleans, or 0, 1, and undefined for numbers, or something like that, but I like it better this way. It is slower than using numbers or booleans, but not by much, and JavaScript is kind of stringly typed anyway. So our input will be a set of gates, and the other part will be a set of connections. Or no, this is not a gate. Something else is a gate. This is a wire. It might be an input, it might be an output, but this is a, yeah, let's call this wire. And then we will have a gate, which will have, yeah, the type, and the type can be AND or 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 XOR. It had its inputs, array of wires, and the output, which is a wire. So, no, this for the input, we don't want it like this. This will be a string pair. And the output is actually a string. which will be the name of a wire, but we can take that later. So we will have our gates, and we will also have the inputs, which is an array of wires. So, which means that we're not using a string array for this, we're using an input. So now we need to return that input. How do we do that? Yeah, let's have this return -1 and -1, and we can turn off the part 2 so that doesn't bother us for now. So the only thing left is actually to process the input. How do we do that? Well, we have some lines at the very beginning which all have the same format, and we can actually split on this. So what we is actually just while take the first line, lines dot shift, and we know that this is gonna be non-empty, and we will just say while line is not an empty line. We're not just gonna console log it, we're gonna add it to the set of inputs. So, which means that we need to take that line and split on a colon space. And we can say that we're gonna take out of that the name and the value. So the first two elements, and there will be exactly two elements, we will take this part into the name and this part into the value. So we can just say inputs.push. We're gonna push an object which we have the name as we took it and the value. It's not gonna be the value because that's a 0 or 1. We can just say if the value is 1, we're gonna put in the true. If the value is 0, we're gonna put in the false. Otherwise we're gonna put unknown. Note that the value will always be a string since we're splitting a string. So we won't get the number 1 here. We will get the string 1. And we're gonna need to return the inputs and the gates. Let's just see if we process the inputs correctly. Console.log the whole input. Let's run it. '24. And we have our values. Let's check them against what we were supposed to provide. True, false, true, true, false, and everything else is true. All the y's are true. We have the y's, we have the x's, and the gates are of course empty. Okay, let's go back to processing. So now we have the lines. Let's see where we are with the lines. We might be having an extra line, we might not be. I don't think we are, but we need to check. So these are the lines that we have left. So let's take that part and let's go to a special place because I don't want to do this with splitting strings and things like that because it's gonna get messy. But on the other hand, this thing has a very, very nicely defined format, which means we have a few letters, was like this or like this. Yep, and it's gonna be more than one. and then we have a space, and then we have an operator that will either be or AND, or XOR. So those are the three options, and then we have a space, and then we have yet another thing made of a few letters, and then we have a space, an arrow, and yet another one of these. So we have 4 items that we want to extract. So in this case, we want to extract X04. Where is that one? Yeah, doesn't really matter. Let's take the first one. We want to extract NTG, extracted, the XOR, extracted, FGS, extracted, and MJIB, extracted. So this is the regex that we're gonna use. So this is a gate regex. Let's write that down. It gave us something, but not something that we want. Oh, we're missing this one. Quite okay. So now we can say, well, lines are basically what we have. So for each line, we're just gonna map, and we're gonna map that thing into a gate somehow. We're gonna return those gates. So right now we don't do anything, we're returning undefined, but we might want to do something like this. So we're gonna match on the gate regex, and this is either that or null. If I say this, will it remove the null, or it only removed the undefined? So it did remove it, so I can have it like this. So we have the match of the second match, which is the operation. We have the first and the third, which are the inputs, and the fourth, which is the output, and that looks like a gate. This time Copilot guessed very correctly. That's great, but still I had to change it, to check it one by one. And moreover, we're already console logging it, so let's see if we're getting what we want to get. Let's also, so this goes only up to a level, so we have the inputs and the gates. So let's log them this way. And now we should also get the value. So the last one that we have is, let's see whether that's the last one we should have. TNW PBM, that's correct, are ORed together to produce GNJ or something like that. So now we are left with the simple thing of calculating these. So we have our inputs and we have our gates. So from the gates, I will actually extract the values of everything in the system. All the wires, so to say. So the wires are not only the inputs. So the wires, we're gonna take not the inputs, but the gates. Yeah, right. I don't think this existed. I mean, we can create a method like that, but it doesn't exist. But I will actually use something like this. Make me a flat map, and we're gonna turn each gate into this array. So this is an array that has the output and the 2 inputs together. So this has 3 elements. And then when we flat map, basically we mash everything together. So we have all the gates. So since this will have loads and loads of duplicates, I will now do the distinct magic. we're going to create a set out of this, and then we're going to turn our set back into an array, and let's log the wires. Those are the wires that we have. Those are the names of the wires that we have. So if we have this, let's do it in 2 steps, otherwise we will get some ugly codes. These are the wire names. So now to get the wires, we're gonna have to map them to a specific wire. So we're taking that name and we're gonna map them to something, not like this, not only like that, but yeah, like this. We're gonna say whether this wire exists in the array of inputs. Yes, it does. Then take the value from the array of inputs. Otherwise, write unknown. So let's now console log those things. So we should get everything that we started with. And I don't like how this looks, so I'm gonna add a bit of processing to actually to sort it. So this is gonna be sorted by name, which means it will be easier to look at. So we have all the intermediate gates, all of them are unknown. We have all the X's and the Y's that are known, and then we have a bunch of Z's that are unknown. This is how it's supposed to look like. So what are we gonna do now? The thing that we need to do is actually run through all of the simulations, through the gates, until we get to a situation when we know all the Z's. So I will kinda assume that at the very end we get a value for all of the gates. But note that we don't need a value for all of the gates, we just need values for all of the Z's. So I will say something like this. Let's just have done. I will have a variable says called done, which will actually be take the wires and is some wire unknown. If some wire is unknown, we're not done. So while we're not done, loop. So what are we gonna do? We're gonna go through all of the gates for of gate of gates. You know what? We're gonna we're gonna need something else as well, but let's leave it like this. It would be better if we have a wire map when we can immediately get from the number to the actual, from the name to the actual value, but sometimes we gonna make this suboptimal and then we can optimize it. See first whether this is actually slow. It could be relatively fast, as long as we are aware that this is suboptimal. We don't want to use an array all the time. Sometimes we want to use a map, sometimes a sorted map, sometimes a set, whatever. Anyway, for now, for each of the gates, we will see, is the output known? If the output is known, we don't need to calculate it again. So what we will see, the output wire is find that wire which has a name that is the same with the gate output. If the output wire's value is not unknown, actually this, we can have it like this. We're gonna continue. Why? Because we already know that. Otherwise, which means we have a gate where we have an output that is unknown. We could calculate it. How do we calculate it? When, if we know the inputs, we can calculate it. So we're gonna find the first input, we're gonna find the second input, and if one of them is unknown, we're gonna have to wait. So we're just inspecting all the gates, hoping to find a situation when we have two inputs that are known and a value that is unknown. If we find that, great. If we don't find that, we just say move on to the next. But if we found it, we're just gonna calculate the output. So we're gonna have something like this. If gate is an n-type, yeah, we can write it like that. We definitely know that there is an output wire, so we shouldn't use this. Or undefined. Yeah, this will take care of it. So we don't need all of this. It guessed incorrectly. I'm afraid I'm gonna have to insist on that. So if both of them are true, return true, otherwise return false. If it's an or, we're gonna calculate it. If one of them is true, then it's true or false. Otherwise, for an XOR, if they're the same, then it's false, otherwise it's true. Yeah, we could have done this a bit better or faster and not use strings to calculate them, but looks okay. So we are have calculated the output wire value, and we're gonna now check if we're done. If we are not done, actually we don't want to do that here, we can do that here, after we passed through all of the gates. Note that if a gate is already processed, it will just be skipped over, so we're not doing any kind of deep processing. So what do we have here? Let's just console log the inputs and see where we are. That was wrong because we wanted to console log the wires. We know that the inputs are okay. We want to see the situation of the wires right now. And now we can see that we made a boo-boo somewhere, as all of them are still unknown even after. So let's take a look at what went wrong. Most likely we're not looping at all. We are done if we are done if every wire is not unknown. This said we are done if some of the values are not unknown. Some of the values are not unknown at the very start, so this is true. While not true, never happens. And note that it generated the correct response here. But we didn't actually get inside the for loop, which means that it didn't work. Let's see what happens now. And this is something else. We have our values. Let's just look at the z's. We have false, 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 true, false. And we were supposed to get false, 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 true, false, a lot of truths, and then two falses at the end, a lot of truths, two falses at the end. That's great. So if we are actually done, we just need to calculate the result. How do we get the result? Well, this is where it gets a bit complicated, because we need to get only the z's. Let's get the z's. Const z wires, not chires. Z wires are, come on, are from the wires. Take the wires whose name starts with a Z and those are our Z wires. And we need to actually take their numbers. I do have a weird idea. We all and I'm gonna use that we already sorted them. So I'm gonna have an assumption here that the Z wires actually don't skip. So we have 0, 1, 2, 3. If we have 13 of them, they are named 0 through 12. And in our case, that is correct. So what we can do now, and we have those Z wires, we can just map them and take the value. So from a certain wire, we not do that. We're not mapping them to a boolean or actually we can do this, and we can say if this is true, then give me a 1, otherwise give me a 0. So this is not gonna be a Z wire, this is gonna be a Z value. And this will be an array that will have ones and zeros, and you can see those are the ones and zeros that we want. So then we need to calculate the result. That's 0, and we're gonna run through that, and we're gonna, if we have ones and zeros, yeah, this is the algorithm when we start. So we're multiplying the result by 2 and appending the value. Yeah, and then we can just return the result. Let's see what this gives us. It gives us 764, and it was supposed to provide this thing. What are we doing wrong? I mean, we have to be doing something wrong. So these are the values. We have them. So the binary number is we're supposed to get the same thing, only in reverse, of course, since we have it reversed. So the number of digits is the same. And if we reverse this, seems to be okay. We're kinda not doing anything. So result is become when we on for the first becomes value. Then we have 0, 1. The bug is somewhere around here, but to be honest, I don't see it. Let's see what happens if we have something known. Const the value is the array of 0, 0, 1. This is 4. Here you have it. Yeah, the 2 multiplication is off because we have 0 and then we're multiplying it by 2. Yeah, we're not gonna need to do that. Oh, this is a very nice algorithm, but this is an algorithm that runs in this direction, not in this direction. So this is the actual 764 binary number. So we needed the values to be like this to get the actual value. Yeah, I knew the algorithm was made sense, only we did it in the wrong way around. And usually you have the digits the wrong way around and then you're pushing them. So we're just gonna reverse those values. And let's see if we have it running right now. Yeah, we do. Let's check if this thing works on the big input. Note that we did have a lot of assumptions. I would half expect, what's the problem here? There shouldn't be one, but who knows? Yeah, we made a lot of assumptions, and I half expect that some of these assumptions will prove to be incorrect, but one way to find out, we got this huge number. So once more, when we get huge numbers in JavaScript, I kind of feel obliged to see if this thing is anywhere around this thing. And one of the reasons why I didn't do 2-bit shifting or something like that, because taking 2 to the 24th power is easier this way, and taking it to the 20th power is also as well, and taking it to the 29th power is also very well, but taking it to the 30th power, great. Taking it to the 31st power, which is supposed to work because we're supposed to have this be correct up to a point, well, it kind of breaks down. Anyway, we have our maximum safe integer, which I think was larger than the number that we got, which means we're safe. This integer is correct in the sense that it's the integer we computed. Whether that's correct in the sense of solving the puzzle, we'll see right now, and it is. We managed to do that. And this was quite easy to do. Now I think that the second part will be a bit more complicated. We're trying to add two binary numbers, one binary number on y as second, attempting to add them, starting with z, great, just one instance of a pair of number. Any two binary numbers should be corrected for the number should be produced as binary number. Okay. We need to 4 pairs of gates whose output wires are swapped. Oh, we need to debug electronics now. Aha. Yay. So now we need to debug this. We need to find out how the binary number addition actually works. If this system is correct, so we have x00 and you can see that x00 and y00 are actually should give us the Z00. But note that we might have a carry. So we need to basically implement a 40-bit addition. And this is gonna be complicated. I'm gonna do a short description right now, but after that we might need to take a break and leave this part for part 2, since it will be quite complicated. I'm gonna be honest and say that at the moment I don't know how to solve this exactly. I'm sure that we will get some ideas later on. But what we want to do, if we have, for example, two numbers that we want to add, and let's say they are 10 and 11, we're talking binary. So this is 2 and this is 3. So now, how do we do that? We can AND using only binary logic gates, because those are the things that actually exist in computers. We don't have a plus in logic gates. We want to implement one. So we can use an OR port here, an OR gate. And that OR gate will give us so we will have, we have 4 inputs. So this is the 1 level input, this is the 0 level input, this is the X, and this is the Y. And let's add 2 as well here. So we're gonna OR these two things. If it's 1, we're gonna get 1. That is one aspect. So far so good. And we're gonna do what with this? If we do an OR, we're just gonna get an 11. Nobody knows. So what we're gonna do is actually here, we're gonna use a few different gates. So for example, one of the things that we need to check is, because we have 4 different options. If we have a 0, 3 different options. If those are both 0, then note that adding 2 binary bits actually provides 2 values. One of the values is the sum, and one of the values will be the carryover. Because if we have 2 zeros, then the sum is 0 and the carryover is 0. So 0 and 0 go to, come on, 0 sum, 0 carry. 0 and 1 and 1 and 0 of course go through 0 carry, but the sum is now 1. But what happens if we have 2 ones? Now the sum actually becomes 2. Yeah, let's write this over here so we can have it a bit better. And this is a plus and plus and plus and plus. This goes to actually 2 different values, because now the sum will be 0 actually, but the carry should be 1. So note what operations we actually need to do here. We need, in order to add this, the sum is 0 if and only if these two are the same. So if these two are the same, then it's a 0. So this is basically describing, depending on these bits, an XOR operation. So this is 0 if they are the same, it's 1 if they are different. And this is actually an AND operation. So we can actually check that in our big input, the processing of X0 and Y0, which is the least significant bit, this is actually the carry bit on the Y wire. And this is actually, this is totally straightforward, so this is completely valid. We take X0 and Y0, we XOR them, and we get Z0. 0. Now, things get complicated if we have a 3. Uh, this was just for a single bit. So if we have multiple bits, this gets complicated because when we're adding these two, we need to take into account whether there was a carry or not. So we cannot just add these two because there's gonna be a third value that's gonna be implicit, that's gonna be carryover from here. So adding these two basically provides us with a 0 on the carry, 1 on the sum. But adding these two, we'll have to add this 0 as well. So we cannot add two numbers, we need to add three numbers. And then it gets complicated and so on and so forth. And moreover, we will need to analyze this whole thing because, yeah, let's see what happens with x01. It's mentioned in 3 places. So here we are XORing with y01 and ending it with 101, and that's about it. What happens with x02? They will enter the value in exactly 2 places usually, and one of them will be an AND and one of them will be an XOR. Actually, it has to be that way, but then we will have this thing connected with something else that is supposed to be taken in some way from the next bit over. So we need to mesh the carry into the addition. And we will need to actually, now I'm getting an idea that we'll need to unravel all of this. We will need to deduce what the combination of ports that we actually need are, and then to check whether we have that scenario. And note that it's relatively easy on the task that only 4 different pairs of items were crisscrossed, so if we know that something that doesn't work, we know with what we actually need to change it. But I think it will take a bit of rewriting of this thing and maybe even simplification. I'm not sure at the moment, but it could be that. Anyway, we got a star. Right now we have about 2/3 of the star possible, 3 stars. Tomorrow is the last day of the event. The event doesn't end there. We can have a lot of fun with it afterwards. So tomorrow we're not gonna have the grand finale. I will need to solve everything and get those 50 tasks and then 50 stars, and then we're gonna get the grand finale, and I'm quite anxious about that, but we will get there. So keep developing, mash the buttons, like and subscribe, and keep developing again.